Good morning once again. So we will now switch to physics, 3rd September 2020. Physics, in the physics we were dealing with electricity and magnetism. We had almost covered most of the topics till yesterday, or in the last class we had covered Ohm's law. In the Ohm's law we had got the relation V equals to IR. So Ohm's law was one of the important topic, and from here we had got the formula for the resistance, which is V upon I. That means when the current is flowing through a conductor, and through a conductor, when the potential difference of V is applied across the end of the conductor, then the resistance offered by that conductor is given as V upon I. Now this resistance is quite important topic. The next topic that I am going to discuss today is the factors on which the resistance of a conductor depends. Factors on which the resistance of a conductor depends. Basically, it depends upon the 4 factors. The resistance of a conductor or a wire depends upon the 4 factors. The first factor is it depends upon the material of the conductor. Material of a conductor. We know that the conductors is basically classified into 2 groups or 2 types, the good conductors and the bad conductors. Bad conductors is also referred to as the insulators. What happens basically is that in the good conductors, suppose this is a good conductor and this is a bad conductor. In the good conductor, there will be large number of concentration of electrons. Electrons will be more. So when electrons are more, there will be more flow of current, and when the current is flowing more, the resistance will be less. So in a good conductor, the resistance is less, whereas in case of the bad conductor or the insulators, what happens is there will be very less number of the electrons. Negligible electrons will be there, so there will be less movement of the current. When you have got negligible amount of the electrons, obviously the current movement will not be there, or will be very less. So in that case the resistance will be high. So when the resistance is high, the current is less. When the resistance is less, the current is more. Okay, so it depends upon the material of a conductor. Key point to keep in mind here is good conductors less resistance, that insulators high resistance. The second is it depends upon the length of a conductor. If you have a very long conductor, the length is more, then what happens is the resistance of a conductor is directly proportional to the length of a conductor. Suppose L refers to the length of the conductor. More the longer the conductor, more is the resistance. Shorter the conductor, the length of the conductor, less is the resistance. So it is directly proportional. Third is it depends upon the thickness or area cross section. Thickness or area of cross section of a conductor. Now see, let us take this 2 example, this 2 pen as the example. This is the area cross section, the thickness of the wire or the conductor, and in this case this is the area cross section. If you compare these 2 wires, obviously this one has got more thickness, area of the cross section is more. So when the area of the cross section is more, the resistance will be less, because there will be more flow of the electrons. There will be more space for the electrons to move. And whereas if you have a small area cross section, then there will be less electrons and the resistance will be more. So in case of the third the resistance of a conductor is inversely proportional to the area of cross section of a wire. The small a refers to the area of cross section. L refers to the length of the conductor. Alright. Then the third and the last factor is the temperature. It depends upon the temperature of conductor. Here the resistance of a conductor is directly proportional to the temperature. That means if the temperature is more, the resistance will be more. Like for example, if you take the filament of a bulb, suppose you have a bulb here, alright, this is the filament, and when the current is flowing through this wire will get heated up. That means the temperature will increase, and when the temperature increases, the resistance will also increase. Whereas when the bulb is switched off, no current is flowing, then this filament is not heated, so the temperature will be less. So when the temperature is less, the resistance will also be less. Alright, so these are the four important factors. These are very, very important, on which the resistance depends. Resistance is the obstruction to the flow of the current. The formula is from the Ohm's law, V upon I. The unit we have learned yesterday, it is also known as the symbol Ohm. It depends upon the material of a conductor, the length of the conductor, directly proportional. Then we have thickness, area cross section. Usually area cross section, it is a circular. So suppose I am showing you the front face of a wire. This is the face of the wire, and it is a circular in shape. It has a radius. So this is a circle. Area of the cross section is usually given as pi r square. Okay, so now from this factors we will get another term that is very, very important. That term is called the specific resistance of a wire, or simply we can call it as resistivity. Okay, so let us learn that term today. The specific resistance of a wire. Specific resistance it is also called the resistivity. Alright, now the specific resistance or the resistivity, we have just learned that the two factors on which the resistance of a wire depend was, number one, the resistance of a wire is directly proportional to the length of a wire or the conductor, and the second factor, the resistance was inversely proportional to the area of the cross section of a wire. Now if you combine these two, 1 and 2, we get, combining 1 and 2, we get that resistance is directly proportional to L by A. We know that L is the length of the conductor, A is the area of the cross section. Now when this proportional is removed, then it is replaced by a constant. Here this constant is given here with a special symbol rho, and this constant is called the resistivity. So here we have rho is constant and it is called resistivity. Resistivity, or it is also called the specific resistance. It's the value of the resistivity or the specific resistance will be different for different material. Suppose I take this to be two different wires made up of different materials, so their value will be different for different materials. So from this formula, from this from this equation we can get the resistivity, the formula of the resistivity. Resistivity is equals to R into A divided by L. So now note, A is the area of cross section of a wire, L is the length of a wire or a conductor. Alright, now what happens is, if you see from here, if the length and the area are both unit 1, then resistivity will be numerically equal to the resistance of a wire. So we can define the specific resistance as numerically equal to the resistance of a wire of unit length 1. Unit length means 1. See, where length is 1 unit and area is 1 unit square. So specific resistance is defined as the resistance of a wire of unit length and unit cross section and unit area cross section. So this definition you can find in your textbook. Please refer to that and learn this formula. So this resistivity is very, very important, or the specific resistance. Now let us learn the unit of resistivity. So all the physical quantities or the terms we have learned so far, all these physical quantities are the measurable quantities, and therefore each of them will have a unit. Alright, so if you look at the resistivity, we have just learned resistance into area by L. If you look at the resistance is ohm, area is meter square divided by meter, or this meter and meter cancel, you will get ohm meter. The unit of the resistance is ohm meter. Some of the key points to keep in mind for the resistivity or the specific resistance is, number 1, it is different for different material. Please note it down. It is different for different material. Second factor is this specific resistance does not depend upon the size and shape of the conductor. It does not depend on the size and shape of the conductor. And another factor on which it depends is the temperature. But here we have specific conditions. It is not that the specific resistance is directly proportional to the temperature. Sometimes with a different material, when the temperature is increased, the specific resistance may decrease, or sometimes when the temperature is decreased, the specific resistance may increase. The first thing is that for metals, specific resistance increases with the increase in temperature, but for the semiconductors, the specific resistance decreases with the increase in temperature. So these are some of the key points which are given there. So you have to make a note of this and write it down, and you will find all this in the textbook. Please refer to that. Now we come to the last term, that is called the conductivity. Okay, now conductivity, like last time, if you remember, we have learned the term that is conductance, and conductance is the reciprocal of the resistance. So today we are going to learn the next term, that is conductivity. Conductivity is nothing but it is the reciprocal of the specific resistance. It is nothing but the reciprocal of specific resistance. So we will write this. Conductivity is 1 by specific resistance, which is given by the symbol rho. Alright. This conductivity has a symbol that, unlike the conductance, in the conductance we did not have a particular symbol, but this conductivity has a symbol which is sigma 1 upon rho. If you go back to this, we have a resistance, and the reciprocal of the resistance is known as the conductance. Today we have the conductivity, which is the reciprocal of the resistivity. Resistance, the reciprocal is conductance. Resistivity, the reciprocal is conductivity, and the unit is also there. We have just learned the unit of the specific resistance, which is ohm meter, or we can also write like this. You can reverse it. So now we have come to the final topic, that is the superconductors. Superconductors are those conductors, or it is a substance where it has got almost zero resistance. The resistance is not there. So when you have no obstruction to the flow of the current, that substance is known as the superconductor. Or it has got infinite conductance. And one thing you have to keep in mind, that it is kept at a very low temperature. So when the low temperature is maintained, a very low temperature is maintained, suppose I take this conductor, I take this substance or a conductor, and it is maintained at a very low temperature. At a low temperature, what happens is it will have almost zero resistance. Resistance will not be there at all, or it will have the infinite conductance. Then there will be maximum flow of current, so that is called the superconductor. It is above the conductor. In the conductor also, you have got some resistance will be there, but the resistance will be less. In the semiconductor, resistance will be slightly more. In the that means the bad conductor, the resistance will be very high. But as you go up and up, you come to a superconductor where the resistance is completely zero. So we have some substances like tin, lead. In that substances, the resistance decreases with the decrease in temperature. Suppose when you decrease the temperature of a substance, the resistance also decreases with the temperature, because we have learned that on the factors, the resistance is directly proportional to the temperature. If the temperature increases, the resistance also increases. Okay, so these are the topics that we have discussed in the superconductor. Examples is like we have the mercury. Suppose if you take a mercury and you maintain the mercury at a very low temperature of 4.2 Kelvin. It is not in degrees Celsius, it is in Kelvin, so it is very less, almost negative in terms of the degree Celsius. So when the temperature is maintained so less, that mercury will behave as a superconductor. You have some other examples also. Superconductors are not common in use because it is very difficult to maintain that low temperature. Alright? So now we conclude this exercise. I'll just give you in a tabular form all the terms or the physical quantities that you have learned. Let us write down this briefly, because these are very important from your numericals point of view. So we are going to do the numericals. Quantities, okay, and symbol. Then you have the formula, and the last one is the unit. The first one you learned is charge. The symbol is Q. The formula is given as plus minus N into E. The unit is Coulomb, capital C. The second you have learned is the current. Symbol is I. The formula is Q by T, and the unit is ampere. The third you learned is the potential difference or the potential. Symbol is V. The formula is work done in moving a charge. The unit is also V, but it is read as volt. Then after that we learn the resistance from the Ohm's law. Symbol is R, the formula is B upon I, and the unit is ohm. Okay. Then you learned the reciprocal of the resistance. It is conductance. The symbol for the conductance is not given. The formula is 1 by R. The unit is ohm to the power minus 1. Then you have learned today resistivity. Symbol is rho. The formula is R into A by L. The unit is ohm meter. Then you have also learned today the conductivity. The symbol is sigma 1 by rho. The unit is ohm to the power minus 1, meter to the power minus 1. In addition to this, you have also learned the Ohm's law, which is equals to V equals to IR. So, in the next class, we are going to deal with the numericals, some of the very easy numericals using some of these formulas here. Have a nice day. Take care. Thank you very much.